morning, students. I am M. Venkataya, Assistant Professor in the Department of Mechanical Engineering at Vignas Lara Institute of Technology. So now I am going to teach the subject is thermal and hydro prime movers. So this is the fifth unit of second topic. So this is the syllabus of fifth unit, that is the hydraulic turbine. In the previous class, I have discussed the classification of turbines and the working principle of turbines and efficiency, calculation and design principle for Feldman wheel, as well as the Francis turbine and Kaplan turbine. The governing of turbines, the performance and the characteristics curves we are discussing in the previous classes. Now, in this class, I have to explain the topics, that is the components of hydroelectric power, electric power plant, and pumped storage system, estimation of water power potential. So estimation of water power potential, estimation of load on turbine, load curve, load factor. We are discussing here the capacity factor, okay, then the load factor. After completion of that one, so we are the capacity factor, then utilization factor, so diversity factor, load duration curves, prime power, then secondary power, so prediction of loads. So in this class I have explained the components of hydroelectric power plant. So what are the components will be there? Here we are installing the dam, reservoir, penstock and the turbine and the magnetic fields. Turbine has shaft. We are that is the components we are discussing from in this class. So see the main thing is hydraulic turbines and hydropower. So this is the fifth unit second part, that is hydropower. So the main components. So we see here in this figure, that is the components of the plant and their role in its working. So here are the basic components of a conventional hydropower plant. So hydropower plant, we have to see here, this is the intake, and totally we are inside, this is the inside a hydropower plant. So this one is the dam water, so reservoir, like this one is a reservoir. This is the reservoir, and this is the control gate to control the control gate. This is the to control the water. So whenever the dam is high height, and that high height the water will send to the down, then it will send to, this is the turbine. When the water will forcefully attack into the inside the cylinder, inside the turbine, the turbine wheels will be rotated. After that the shaft will be rotated. Then the magnetic field. This is the transformer. This is the help of generator and transformer and powerhouse will be there. This is the transmission lines or power lines. Then we are utilizing the powers. Okay. So this is the overall view of inside power plant, hydro power plant. So we have to see here, this is the intake, this is the main components. We are discussing here the reservoir. So what is meant by reservoir, and the dam and the generator. This is the reservoir. We are discussing here only. So reservoir, and this is the intake water. This is the control gate to control the water high speed water we have to control. And then this is the penstock. This is like penstock. Then this is the turbine. So turbine. Then the outflow. Then it will the river. This is the outflow. Then it is a river. Okay, so this is the turbine, and it is the shaft, and this one is the generator. This one is the generator, and this one is transformer. Then finally this one is powerhouse. And whenever the power will be produced, that power will transmission lines. The power will send to the transmission lines or power lines. Transmission lines or power lines. Okay, this is the overall view of hydro power plant, and this is the main. These are the main components of the hydro power plant. So see the main components of hydroelectric power plant. So the reservoir, first of all, we are discussing about the reservoir. So water from a natural water body like a river is storage in the reservoir. Okay. So the water, this water will be the water from a natural water body like a river is stored in the reservoir. So water will be stored at a particular location. Then we can say that the reservoir. So this reservoir is built at a level higher than the turbine. So built at a level higher than the turbine. So this is the turbine. So here this reservoir is built at a level higher than the turbine. This is the turbine. So water will storage from here only. So that is the higher than the turbine. Water will be stored. Then the second one is this is the dam. So the dam, the flow of water storage in the reservoir is obstructed by huge walls of the dam. Then this prevents the water from flowing and help us harness the energy present in it. This is the intake, and this gate is very control gate. That control gate is very important here. Then the dam consists of gates present. This is the gate, intake gate or control gate. This is the intake and this is the control gate. So the dam consists of gates. So present at its bottom, which can be lifted to allow the flow of water through them. Okay, flow of water through them. Whenever the control gate will open, that water have high speed. So that water will send to directly turbine. So when the turbine have some blades, at that particular blades will rotating speedily. Then that turbine will connected to the shaft. This is the shaft. Then in that particular shaft will connected to the generator. That generator will the main function of the generator is the mechanical energy will convert to the electrical energy. So then it's called the generator. So that generator, whenever we are installing here the generator, the main function of the generator is the mechanical energy will convert to the electrical energy. Then it's the power will be produced. That power transformers will be there. That powerhouse transformers we are installing in that powerhouse. That powerhouse will the power will be sent to the power lines or transmission lines. Okay, the main penstock. So we have to see here. This is the totally penstock. We are calling as penstock. This connects the reservoir with the turbine propeller and runs in a downward inclined manner. So downward and inclined manner. This is the inclined manner. So the water will send to the turbine. Okay, inclined manner. Then when the gates of the dam are lifted, the force of gravity makes the water flow down the penstock and reach the blades of the turbine. whenever the water will reach the turbine, in that turbine have some blades that blades are rotating speedily. Okay, so as the water flows through the penstock, the potential energy of water storage in the dam is converted into kinetic energy. So once again I repeat, as the water flows through the penstock, this is the penstock. So water will forces. So the flows through the penstock. The potential energy of water storage in the dam is converted into the kinetic energy. Then the next, this is the turbine. This one is a turbine. So the kinetic energy of the running water turns the blades of the turbine. So the running water, the kinetic energy of the running water runs the blades of the turbine. So the turbine can be either a Pelton wheel model or a centrifugal type. So for Pelton wheel model, we are using the centrifugal type models and as well as the Pelton wheel type of turbines we are using here. Okay. Then the turbine has a shaft connected to the generator. So the turbine have shaft. That shaft will connected to the. This is the generator. Connected to the generator. Okay. Then the most common type of turbine for hydropower plants is the Francis turbine, which looks like a big disc with curved blades. So we have to see here in this the turbine, the most common type of turbines we are using in the hydraulics, that is the Francis turbine. That is Francis turbine, which looks like a big disc. So that has the big disc will be there. So at that particular we are seeing like a big disc with curved blades. And then a turbine can weight as much as 172 tons. Okay, a turbine can weigh as much as 172 tons and turns at a rate of 90 revolution per minute. So 90 RPM. 90 RPM means revolution per minute, according to the Foundation for Water and Energy Education. Okay. So in this class, what I have discussed is the first thing is the components of hydro power plant. Then these are dam, reservoir, turbine, like Pelton wheel, and Francis turbine. Okay, that is the components and the working principle of hydropower plant. Working principle of hydropower plant. This topic I will explain next class. Okay.